Okay, so for domain, it's all the x values allowed. Okay? And so in a sense, you're thinking of horizontal movement. Okay? Range is the permissible y values. You're thinking of this, right? So this could probably make it onto your study sheet if I were you for domain and range. I will just say very clearly here, no word problem. Like there's no word problem associated here yet, okay? But I'm going to give you some examples here. If you have a parabola that points down, right? So obviously A is negative. You must know the vertex in this case. So if the vertex is, let's say, 2, 4, then your domain here, how about we do the domain on the side? It goes to negative infinity to positive infinity. Like because of the arrowheads, it just never ends. Okay? But the range, I kind of project this onto my y-axis, guys. I project it. So I will take the top part and I'll make a little line here. I'm not allowed anything above it, but this keeps on going down. Okay? So for the range, I would actually encourage you to do this every time, right? For the range, the highest we get is 4, right? Due to this y value, right? This y value is what tells me how to find it. And where do we go? Like if there's arrowheads on both legs, so this continues to go down indefinitely. So it goes to negative infinity in this case. So I'm going to do this right on the side here. Oh, how about I do this? To translate this into proper notation, you would go negative infinity to positive infinity. You actually go D and then colon, and then you write that down. That's the proper notation. However, if you don't do the D part, that's fine. The only exception would be if I ask you for the domain and for the range, you got to tell me specifically which one is which. So this would be one way of doing it. Either you write it underneath saying this is my domain, and so that's the domain, and if it's set notation, in this case x belongs to all real numbers. Okay. So this is interval. Interval, and this is set. Okay. For the range, let's do the interval first. Put down the numbers or put down the values first. So which one of these is smaller? It's negative infinity. The more negative you are, the smaller you are, right? So you go negative infinity first, and then 4 second. And you put a square bracket around the number, you put a round bracket around the infinity. Or you can use set notation, and so the y values would have to be less than, so less than or equal to 4. Okay? So that's kind of like this scenario when A is negative, right? A is negative, this is kind of the pattern that you can observe. Mind you, for the domain, nothing really changes. Like whether it's pointing up or down, if there's arrowheads on both ends, it's just going to go to infinity. Okay, so let's do this part right here. I'm going to do another one. If A is positive, how do things change? and it's imperative that you know what the vertex is. The vertex could be anything, right? So don't be fixated on these numbers. So let's say this is -3, -7. Okay, so for your domain, this is going to continue on in terms of the x values, positive forever, right? And into the negative infinities as well. Right, so positive, negative infinity. For my range, we project this onto our y-axis, right? It's going to go -3. There's nothing below it. There's only something above it like this. So for the range, you're going from -7 all the way to positive infinity. Okay. So your domain in this case would be negative infinity, positive infinity, or x belongs to all real numbers. For the range, write down these values in the correct order. So -7 is smaller than positive infinity. So you just got to make sure you get that right. And we can include the -7, but we cannot include infinity. Or, in this case, the y values would have to be greater than -7. Greater than or equal to -7. Do you remember open dots in the intro? Open dots, like if it's just a circle, not a solid. That means that we don't include that point in and of itself. So if this had been an open dot, we would not put a square bracket around -7. We would just go round as well. It doesn't really happen very often, so I'm not going to stress on that right now. Let's do two. These are like general examples. Let's do some odd ones. Okay, so I'll ask you to copy at least 2 of these. So let's say you would have something like this. And this point right here, let's say this is -5, 3, and the vertex is -2, 6. So imagine something like this. So this one doesn't continue to the left forever. It doesn't go that way. So for your domain, imagine this. Portray this point onto your x-axis. So you know it goes from here to, this one just opens up indefinitely. So we're going to go from -5 for our x, right, all the way to positive infinity, because this keeps on opening up indefinitely. For the range, you're looking at y values. So you want to portray this one here. Why not that one, Mr. Erickson? Because this is like the furthest, the uppermost point, right? So I care about how far above do I get and how far below do I get. So this one would be a 6, right? If the y values is what I'm interested in. Does this continue to negative infinity forever? Yes, because of this leg, this thing keeps on going indefinitely. Yes, this other leg here doesn't continue, but it doesn't matter. You see graph, right? So we would go negative infinity here. This is my range. You know what? If you could do this even for yourselves, as you see a graph, as you do a little sketch and then state it, it would be probably very helpful. So for your domain, we would go from -5 to infinity. For the range, we would go from, you got to get this right, negative infinity to 6. So it looks different, okay? This is infinity, by the way. Or let's do the set notation. What would we say, how would we write this in set notation? X has to be greater than or equal to -5. Okay. This one here, the y values have to be less than or equal to 6. Maybe I'll tell you, I'm thinking of ways to help you out with domain and range, guys. I will say this. How do you know is it greater than or less than? I would say anything to the right is greater than or equal to. Anything to the left is going to be less than or equal to. Okay, for your domain. For your range, if this is like the origin, anything above will be greater than or equal to. Anything below will be less than or equal to. So if that's something you need as well, add that to your study sheet under domain and range. Domain and range is one of those things that on a test, for example, you can expect about 4 marks out of 40. That's like 10%. It's gonna keep coming back in grade 12. It's gonna keep coming back. So I'm gonna try to kind of drill in domain and range as much as I can. So I'll have just short activities where you kind of have to think about it, right? And come up with a proper notation. Today I'm gonna actually ask you to state both every time. So you get really comfortable with the domain and range. Any questions? I hope this helped. Yeah? It's a tough concept. So I'm trying different